Hi there, Lisa. Okay, so we're on the broadcast. So I've started our PowerPoint um, for for our classrooms. I'll just do a brief introduction. Elisa Dong is currently pursuing a master's in geophysics and studies in earthquakes. She wants to be able to predict earthquake sequences by using the power of getting computers to do things for her. Currently, she is entertaining the idea of dealing with Martian seismic data to better understand the Martian interior. So I'm going to turn this over to Elisa. We may continue to have a couple of technical difficulties, but between Elisa and I, we will get ourselves through the presentation. And just a reminder, if you have any questions, please enter them in the Q&A window. Over to you, Elisa.
All right. Hello, everyone. It looks like I have control of the screen now, so fingers crossed that everything works. I am having a few internet connection issues, so hopefully we'll stick around long enough. So I'm here on behalf of Western Space and junior astronauts to talk to everyone here today. So let's start off with like a brief explanation of who I am and why I'm talking to you all today. Let's see, haha, it works. The first thing I wanted to share with you guys is that my latest adventure recently has been that I've joined the fencing team at Western. It's a great amount of fun. It's something to do while trying to get that work-life balance. Some other things to know about me is that I am a great cat lover. This is a photo of me taken in Japan, where we decided to go to a cat island, managed to not find it, and found a bunch of stray cats everywhere else to go pet on the streets. Some other things to know about you. I am somewhat interesting. I like to travel. I'm here on a city cat in Brisbane, Australia. And in my spare time, often there is a lot of things I like to know about. So I take photos of things that confuse me. For example, this was a photo taken on the beach, a bunch of paw prints that had 5 claws, and I didn't really understand where they were coming from. So I took a photo to kind of store in my to-do list to figure out later what it was. Also relevant is that I greatly enjoy photos of like nature, scenery. This is actually Heron Island on top of the Great Barrier Reef. And lastly to know is that as a grad student, I am an obligate coffee addict. And in terms of academia, I'm also part of the Western Multi-Hazard Risk and Resilience Group. So we're a group of academics and industry personnel, as well as government officials that want to work on resolving hazards, especially hazards that are related to each other, that we call cascading hazards. In my particular instance, I'm interested in the effects of earthquakes and then tsunamis, but also like when we have tsunamis, power outages, will we also get fires? So this is a group of people that kind of wants to work together to resolve these issues and to provide information for each other. And I suppose the final thing is I wanted to share with you that as an academic studying something very specific, I'm not limited to only doing these things. If I can get the slideshow to work. So let's talk about today's weather. It somewhat works. Okay, so today's weather. This is a screenshot taken from an application called VentuSky. It shows us the temperature across Canada, which I presume most of my audience is at. The image beneath that I originally wanted to show was the relationship between the wind speeds and the temperature. The idea being that a lot of science now is done on computers and we do a lot of modeling. From looking at the relationship between the wind speed and the temperature, we can kind of predict today's weather. This is relevant to space, being that space also has weather and it's greatly affected by the sun. This is an image taken of the sun's coronal mass ejections. We can see just like those jets shooting out. That greatly affects the weather we see on Earth. And it also affects the weather on Mars. This is the Mars Insight weather report. We can see now that with InSight on Mars, we can get air temperatures and pressures as well as wind speeds. So briefly, a little more about my own research. I study earthquakes, and ideally I'd like to predict where and when earthquakes happen, especially for really big ones. A more glamorous photo, this is the 2011 Tohoku earthquake, where there was a very large tsunami that overflooded and overtopped these seawalls. We can see this cascade going down. I don't actually go to these sites for the majority of the time, though there are plans in the summer to go. What I actually do is slightly less glamorous. I look at numbers for most of my day. A lot of working with large data sets, and also just like plugging in relationships. And I know for my audience, this does not seem super glamorous, and admittedly, it's not. But my work can also be thought of like as a series of dominoes. We have a bunch of parameters and variables that we're concerned about. We want to see if we nudge our system a little bit, if we nudge our dominoes, like what kind of falling effect do we get? So that's like an alternative way of thinking about the way I do research. Is I have a lot of dominoes lying around, and I like want to give them a really good kick and see if anything happens. And then once something happens, I report it, I record it, and I look at why it happened.
I jump in for a second, Elisa. On the topic of your dominoes, what are some of the dominoes that you might be kicking around to make change?
Sure. So I'm specifically looking at like spatial distribution. So things like fault geometry. So we have tectonic plates that are colliding, and sometimes in certain regions called subduction zones, we have plates that go like underneath each other. So I want to know at like what angle do they go underneath each other, how fast they're moving, like is there friction involved, is this kind of motion continuous throughout the entire length of the fault. We also look at things like what is the composition of the fault zone, what kind of rocks do we have in that area, how strong are they ductile, will they break under pressure, and those are some like general parameters that we look at when it comes to space. When it comes to time, the variables are a little less well understood. We call them A and B parameters, and there's a bunch of mathematical relationships that can describe these. Is that good?
Yeah, thank you.
Cool. Yeah, so my specific region of study happens to be in Canada on the west coast, off of British Columbia. We have this region called the Cascadia Subduction Zone. And we know from both geologic studies of turbidites, which are these rock sequences in the geology, as well as stories from like the Native Americans, that every 400 to 700 years, we have a really large magnitude earthquake happening, roughly magnitude 9. In energy equivalents, that's about 25,000 nuclear bombs going off at once. So ideally, we'd like to know when and where these things are going to happen, but not only when that one major event is going to happen, but what happens right before it and what happens for the 10 years afterwards. Because the 10 years afterwards is pretty important if we want to move back into this region. So working on this rather important thing to us Canadians, if anyone happens to be living in this area, it can also have a huge impact on our economy. So ideally, we want to prepare as best as we can for something like this happening. So we'll jump back into space. Why is my work related to space? There are quakes in space. We try to, I still call them earthquakes, and I probably will for the next little section. But unfortunately, they don't come from these like flying dragons out in space. I know this is Dragon's Den today. Instead, some of them in our own solar system come from these coronal mass ejections that I showed in the weather report earlier. And this is due to magnetic anomalies in the sun. We also get things like neutron stars ripping themselves apart under the force of their own gravitational fields and magnetic fields. We can register those via pulses in telescopes. Closer to home, the moon also has quakes. In the past decade or so, the information from the seismometers on the moon are giving us information about like, do we have a core in the moon? Do we have a mantle? Do we share a similar composition as to Earth? And something else that's been studied is like where these quake sources are coming from. On Earth, a lot of quakes come from tectonic movement. On the moon, a little less so. We also might have quakes on Mars. So a proposed project, it's currently running, is to place a seismometer called SEIS on the surface of Mars. And when an impact strikes the surface of Mars, or if there is any like tectonism occurring on Mars, we should be able to detect when and where that came from and a precise location through this complicated series of matching waves together. This is what the detector actually looks like. It's just, this is like an artist rendition. It's been plopped on the surface of Mars and has been recording ever since late 2019. This is an image that the group that is running the experiment has shared. There were two relatively large Mars quakes that happened in an area called Cerberus fossae. And they're not sure why yet, but these are like the most promising things we have found so far. And the last thing I saw on their Twitter when I was scrolling through was that there's like some strange background signal that we don't really know what it is, but it's helping us identify a lot of these large magnitude events on Mars. And then some really quick recent stuff. This slide didn't work super well, but Artemis is something that's going on. Hopefully we're going to be building a method to help humans get to the moon more frequently, do more experiments, put more seismometers down. Canada is playing some role in this, and we're also working potentially on Canada Arm 3 for the Lunar Gateway. And this is just an image of Canada Arm 2. And now to the main event. I'm here to talk to you guys all about junior astronauts.
Oh, sorry, Elisa, before we jump into junior astronauts, can we just circle back a little bit? One of your early slides talked about earthquakes and tsunamis. Can you just explain a little bit of the relationship between earthquakes and tsunamis and whether that's also something that's pertinent in those lunar bodies and sorry, in the moon and the Mars and what have you? Is that same sort of situation pertinent there?
Sure. Let me see if I can actually see the chat box. I'm not able to see these questions.
Oh, that's all right. That was just a question I'm bringing up. It's okay.
Okay. So let me see what I can say about this. Just go back. So earthquakes and tsunamis on the moon, we won't have things that are similar to tsunamis on the moon. The formation of a tsunami typically happens when there is a large disturbance in the water level in the ocean. And in terms of an earthquake, usually that's because a portion of the land has suddenly dropped or suddenly gone up, and the water correspondingly goes up and down, and that generates a large wave of water we call a tsunami. On the moon, as far as I know, we don't have liquid water, so something like that shouldn't be happening, but we might have disturbances of lunar regoliths, so little bits of dust and particles on the surface of the moon that might be disturbed by similar quakes. But the intensity of the quakes on the moon are relatively much smaller than the ones on Earth. For a tsunami to occur with any sort of significance on Earth, it has to be above like a magnitude 7. So I don't think we see anything similar or equivalent on the moon.
Great. Okay. Thank you.
Yeah, of course. Yeah, let's go to junior astronauts, which is what we're all here for. Junior astronauts. So as I understand, the Canadian Space Agency is looking for astronauts of younger ages, so junior astronauts. They want to encourage students to explore space, explore their interest in space in multiple venues. There are ways to be a scientist or someone just interested in space in multiple areas. So some of the careers they've laid out as an illustration is that we need people in geology. So it's kind of similar to what I do. People studying rocks, people studying lunar analogs, people studying Martian analogs. Biologists are also incredibly important. If we ever want to live in space outside of Earth, we want to know how microgravity experiments work. If we grow plants with zero gravity, how do those work? How do they absorb water? We need doctors for our astronauts, the people exploring these locations. When they get back, how is their health? Can we maintain living on Mars or the moon for long periods of time? And there are a lot of other jobs out there that are space related, that are crucial to the space industry and that are really important to exploring the fringes outside of Earth. What can we do with all of this? So the Canadian Space Agency is encouraging all of you to consider a job in space if you are at all interested. And there are a lot of ways to get to space. So today, I believe all of you are here to work on the Dragon's Den project. There you go. 1 second. The Canadian Space Agency is running an event to allow people such as yourselves to potentially train as an astronaut if you complete these 3 projects. report to them, hey, I've done all these 3 projects. I've done Patchmaker, I've done Dragon's Den, and I've done Survivor Moon. They want to know that you are thinking about space. And then once you've done these events, you as yourself can apply to go to the Canadian Space Agency and train with astronauts. And your classroom, if you do any one of these projects, can apply to them to potentially have a real life astronaut come to your classroom. So hopefully all of you have heard about Dragon's Den before I'm talking about it and have maybe looked at what the project is, but I'll just briefly go over it again. So Dragon's Den is a competitive environment. Usually you have a really cool idea and you want to share it with someone who can help you support that idea. In this instance, we have 4 panels, 4 groups of people you want to present your really cool idea to. The first one is the astronaut panel. You want to be talking to astronauts and telling them, hey, I have a great idea to make your lives better as astronauts. I have a really cool idea for what you can do in space, out of space, before you go on your event. And how do you recover? So if you have some really interesting ideas for astronauts to make their lives a little better, this is the panel you'd be going to at the Canadian Space Agency. The CSA has some tips on what kind of things to consider when presenting these. You want your project to be very practical. Ideally, it's like on the small end, so it can be done very quickly. And they don't want to be using new technology. So use something that is already existing and propose it to these people. The next Dragon's Den is the engineer panel. You've worked really, really hard. You've come up with a new robot or some new technology, and you want that to go to space. You have a really cool telescope that you want to go to space. So you want to convince the Canadian Space Agency that you should build this technology and get that into space. So you want to convince them that this technology will be useful in space and it's going to be useful long term. This is a more technical project. You have some sort of robotic or computer program or physical device that could be really interesting in space. The politician panel is if you want to fight for funding for the Canadian Space Agency, you should convince Canadian politicians that we do need money to explore space. Our budget is much, much smaller than some of the other space agencies out there. And Canada is potentially falling behind in the space race. And there are some benefits if you can convince the politicians that space technology can help people in Canada and can help people on Earth. This is the panel you want to go to. You want to talk to those politicians, be very convincing and say, we need money from the government. We want the government's name on this project. You want to go talk to the politician panel. And the alternative to talking to politicians is talking to CEOs of private companies who are also very wealthy and often very flexible with their money if you can convince them that your project will make them money. So if you have an idea that you think is really useful in space, but also very profitable, this is who you want to talk to. You want to talk to industry partners. You want to talk to the CEOs of companies who have money to invest in cool new projects that both help with space development and exploration, but also are useful on Earth. So that's just a summary of all 4 panels that you might experience or might want to talk to if you're doing Dragon's Den. And some things to remember when you're talking to your audience, like who are they? What is their goal? The CSA wants the astronauts to be happy and healthy. They want to know that your project is useful to them. The politicians want to know that the project you're proposing is useful to Canada. And the CEOs of the industry partners want to know that you can make them money. So I wish you all luck. Hopefully some of you guys have already started on this. And I think that wraps up the introduction to junior astronauts. Remember that you can apply to the CSA to go train as an astronaut if you actually go complete this project.
Excellent. I'm just going to stop the share. There we go. And I just wanted to remind classrooms that if you have any questions, you can put them in the Q&A channel and I'll relay them to Elisa. So Elisa, wanted to ask a little bit more about your research and its impact on the space program. So what would be the implications of finding that Mars or the moon were had highly active seismic activity?
I think a lot of the reasons we're doing these, like as academics, is that we think these are really cool. I guess our first priority is like, this is really cool. This is something new. But what are the longer term impacts? This can help us understand the formation of the solar system. If we understand that Mars has quakes and we know that the quakes are coming from either tectonism or cooling of the mantle and crust, this might change our worldview of how the solar system formed and how geology works. So whether or not our understanding of Earth formation was correct can be influenced by Mars, and that impacts our long-term planning for will Earth break up into a new continent. There are a lot of large-scale relationships when it comes to quakes, particularly just some fundamental knowledge about whether or not we understand, minerals and chemistry as well as we think we do.
So you talked about the potential that quakes are related to tectonism um, or on Earth. What are quakes? Are quakes deriving from both of those?
So on Earth, we have one major source of earthquakes, and that is tectonic activity. This happens at both subduction zones as well as transform faults. So those are locations that are very common. That is tectonic activity. So transform faults, we have two sliding plates. The famous example would be the San Andreas Fault in California, where as you grind across each other, these little edges are really rough and they catch and slip. Those release earthquakes. The other common one is the subduction zone I was talking about, where one plate is descending on the other. And this one actually has a tendency with the potential of larger earthquakes, because the rock undergoes different phases of ductility, which means it's a little plastic for a while. It can retain a lot more strain and stress. And when it finally snaps, it's possible to get magnitude 9 earthquakes. So that's tectonism. And then the other semi-common source of earthquakes is actually due to crustal cooling and heat distribution from the mantle. So the crust reacts to things such as like glacial rebound, the mantle upwelling, a lot of things that are not related to the crust actively breaking and reshaping itself. So temperature cooling of the crust can release quakes because there's an energy change when that temperature change happens. Or when glacial rebound happens, the Earth crust suddenly like pops up again. That might generate some quakes as well. I also see a question from Karen.
Yeah, so we have a question from Louis Riel School in Calgary, the grade 8 class, asking about a prediction for the big earthquake on the BC coast, and would Victoria be at risk of a tsunami?
That's an excellent question. I'll give you a little background. The last time a major event happened was in 1700, and so that was a little over 300 years ago. The rough recurrence interval is every 500 years. So if you believe that without taking into consideration any randomness, any statistics, the next one would be in about 200 years. But we know there's a lot of variability in this, so the ranges widen to 400 to 700 years. In theory, while it is unlikely, it could happen much sooner. That's something we're trying to work on. We still don't have enough information. The recurrence intervals of 500 years is pulled from geology, and we only have, I think, 7 of those, and that's not very good for making an estimate. So that's why we want to work on it. Hopefully it doesn't happen tomorrow.
So that prediction model, that goes to your slide at the start when you talked about moving the dominoes around, and how can you change some of those parameters to understand when quakes are going to occur?
Yeah, it's very similar. It's something I'm working on developing right now. I know other people, maybe a little smarter than me and have spent more time working on this, have better ideas, but there's still a very high degree of uncertainty as to when these things will happen. Often large earthquakes for subduction zones come with some sort of trigger warning, such as foreshocks. So we want to be looking at simulations of major earthquakes and looking at, do they come with foreshocks and do they come with aftershocks? Particularly in the foreshocks, those might give us a time window of when we can predict more precisely when such an event might happen. But it's somewhere on the order of decades. And to answer whether Victoria would be risky at a tsunami, I will have to look at tsunami simulation models to answer that. But I know the government of Canada has released a hazards map that you can kind of look at to see if the region you're living in will be at risk of tsunami.
So if anyone was going to be, it might be Victoria. Is that, yeah.
So that entire coast is at risk of tsunami, to be honest. There is like an island, Vancouver Island, that will actually protect a lot of the coast on the inside when the tsunami happens. But the tsunami, as it like breaks over that, over Vancouver Island, the maximum height might decrease, the amount of energy might decrease, but there's a lot of detailed modeling going along for areas such as like bays and coastal inlets, and it's all variable across the coast for just how large a tsunami might be.
Okay, so L'Oreal also just asked whether there's any other evidence of quakes outside of Mars, Earth, and the Moon. Has there been study on other planets? Do we have any evidence that there would be quakes elsewhere?
I do know Venus quakes exist. I haven't looked into why they exist and what they're from. It's very, very hard to study Venus since its atmosphere is really dense and it's quite hot. So quakes on other planets do exist. We just don't know as much about them because we haven't sent anything to go study them in detail yet.
Gotcha. And then also asking if the seismic activity on Mars is similar to here on Earth.
It is not, in my personal opinion. It depends what you consider similar. Seismic activity on Mars has thus far, as far as InSight has measured, as SEIS has measured, is typically lower than magnitude 3. So over the course of half a year, we haven't had any events over a magnitude 3 happen. We also have to remember that the tectonic activity on Mars is, by most people's opinion, no longer happening. So the larger events are very unlikely on Mars. We don't have that level of activity. So what we have is closer to something that we call background seismicity on Earth. That's probably what we're getting on Mars. So like a portion of the seismicity is similar, but it's not a replicate of Earth by any means.
Okay, so we're getting pretty much to the end of our time. I just wanted to ask my favorite question, and that's, how does somebody find themselves at the University of Western Ontario studying earthquakes? What's your educational path that gets you to here?
I have wanted to study natural disasters for a long time. I did happen to apply to geophysics for my undergraduate at the University of Waterloo as kind of a random event. I was originally applying for engineering. I poked around the engineering options, realized that one of the earth science options was really, really similar to the engineering option and like half the tuition. So that was quite important to me. So I opted to go to Waterloo for earth sciences, and I decided to specialize in geophysics because at the time, my thinking was geophysics sounds like the hardest option that they had. This is untrue, by the way. But I was like, I'll take geophys because it's hard, and if I don't do well, I can drop and switch programs. So I did geophysics. And in my final year, I was like, do I want to do grad school? I don't know where I'm going with my degree. I don't know what I'm doing with my life. And you know what? Something I've always wanted to do is study natural disasters. I've done a bit of study in other areas as well as part of work in co-op. But I think what I did is I poked around some university websites. I looked at some profiles of professors and saw what they were studying. And I was like, hey, this one professor that I contacted has interest in something I'm interested in. And I think I could dedicate 2 years of my life to doing. So I emailed them and I was like, this is what I'm looking for in a supervisor, which is very straightforward. And this is what I can provide. That is how I managed to get to University of Western. This is pretty much being a little active, thinking about what I was good at, what I needed assistance with as well. So what I'm looking for in a supervisor is very important. And what I wanted to do with the rest of my life. I knew I liked science. I roughly know what the grad school life is, lots of coffee is the main one, if you drink coffee. But yeah, I think it's just like taking the opportunities as they came, talking with my professors, but also even prior to undergrad, just talking with my teachers in high school and be like, what do I do with my life? What do you think I'm good at? And their feedback was very valuable.
Excellent. So one last question just popped up and then we'll have to go, asking about whether the same mathematical relationships relate to predicting quakes on Mars or on the moon.
The hope is yes. So for prediction, there's a suite of models out there that can roughly predict the time occurrence and the location occurrence of earthquakes on Earth. A lot of those are related to fault zones. On Mars, we don't quite have those, but some mathematical relationships we have that are pretty much universal as far as I understand, also applicable to star quakes. One of those relationships is called the Gutenberg-Richter relationship, which basically states that as the magnitude of your event increases, the likelihood of it, the log likelihood of it happening decreases. So that seems to be a relationship that seems fairly universal. The difference between doing it on Mars and on Earth, we can't say this relationship fits perfectly, is because our seismometers on Earth are actually not that sensitive. There's a lot of background noise, so we can't be checking those magnitude earthquakes to see if they fit that relationship. But if we scale it up, it seems like it should work. So hopefully what I do on Earth is also applicable to Mars.
Excellent. That's a great way to end it. Elisa, I want to thank you very much for your time today.
Thank you for hosting, and thank you everyone for coming.
And thanks to our classrooms for being a part of today's session. We will be taking a week off next week from junior astronaut programming. The next session will be the week following next, and a promotional email will be coming out next week. Hopefully classrooms can get on sessions, and I look forward to seeing all of you back for our next one. Thanks a lot. Take care. Bye-bye.